This videotape deals with solving quadratic equations by factoring. We're going to discuss how to solve a second degree or quadratic equation in one variable. For example, something like this. X squared plus x equals 30. A quadratic or a second degree equation in one variable x. To solve this, I'd like to find all those x values, all those real numbers which when substituted for x would make this a true statement. Okay, first let's make it clear what is not solving the equation. In other words, if I write x is equal to 30 minus x squared, this is not what I mean, okay, by solving for x. This is not solving for x, just saying x is equal to 30 minus x squared. I would like x alone on one side. For example, x equals some number. Okay, that would be a solution. So this is not what I want. Okay, when you want to solve a quadratic equation, it's very convenient to first put the quadratic equation in what we call standard form. That is, everything on one side, ax squared plus bx plus c, everything on one side of the equation, 0 on the other side, where a, b, c here are constants and a is not 0. If a were 0, of course, we would not have a quadratic equation. We would not have a second degree equation. Okay, a is not 0. Furthermore, when I'm solving an equation by factoring, I find it convenient if my lead coefficient here is positive. So, for example, if a were negative, I might want to start by multiplying both sides of the equation by -1. Okay, so that a would be positive. This is going to be standard form for a quadratic equation. And we start our solution. In general, when we want to solve a quadratic equation, we start by putting it into standard form. Everything on one side equal to 0 on the other. Now, the reason we're interested in having 0 on one side of the equation is that 0 is a number with a very special property. If you multiply two numbers and their product is 0, for example, if you have two real numbers, let's say a and b, and a times b is equal to 0, then I can make a definite statement about a and b, the fact that a or b has to be 0, possibly both. At least one of these, possibly both of these numbers must be 0. If the product of two numbers is 0, then one or both of the numbers must be 0. Okay, let's write that down. If a, b is 0, a and b are real numbers, then either a equals 0 or b equals 0 or both equals 0. If the product of two numbers is 0, then either one of them is 0 or possibly both of them are 0. Now, I can't do that with a number other than 0. For example, if I say the product of two numbers is 12, I cannot say anything definite about the numbers. The product of two numbers is 12. Well, maybe a is 4 and b is 3. Or maybe a is 6 and b is 2. Or maybe a is -1 and b is -12. There's nothing definite about this. Okay, or a could be 1/2 and b could be 24. Okay, obviously, tremendous number of possibilities here. Nothing definite about a or b. What makes 0 special is that if the product of two numbers is equal to 0, then for sure, at least one of the numbers has to be 0, possibly both of them. Okay, so that's what's special about 0, and that is why we would like to get everything on one side equal to 0, okay, on the other side. Okay, when we solve quadratic equations by factoring, the trick is to try to factor this trinomial here in x and think of that as, say, the product of two numbers equals 0. Now, not all quadratic equations can be solved by factoring. The technique that I'm going to show you in this tape is factoring, but not all quadratic equations can be solved by this method. If you can't solve a quadratic equation by factoring, it does not mean that there is no solution, no real solution to the quadratic equation. In the next few videotapes, we'll be learning other techniques for solving quadratic equations that we can use if factoring fails us. Okay? But for those quadratic equations that can be solved by factoring, you'll find it a very convenient technique. Okay, so we start by getting everything on one side equal to 0. Let's look at the problem that we're working with, x squared plus x equals 30. And let's work that out. X squared plus x equals 30. We start by putting the quadratic equation in standard form. That is, we subtract 30 from both sides of the equation and get x squared plus x minus 30 equals 0. We now have everything on one side equal to 0 on the other. Furthermore, the lead coefficient here is positive. It's 1, so we're in ideal form. What we would like to do is try to factor this trinomial. Okay? If I could factor it, then I would have it in the form sort of like a product of two numbers equals 0, and I could then set each of the numbers equal to 0 to get possible solutions to this quadratic equation. Okay, now if you're unsure about how to factor a trinomial like this, I would refer you back to the earlier tapes that we've done on factoring, either in the 06 sequence or in the 04 sequence. We have several tapes discussing how to factor a trinomial. Okay, the basic thing here is that I'm looking for two numbers that multiply to minus 30 and add to plus 1. Okay, and without too much thought here, we can say that the numbers must be plus 6 and minus 5. In other words, we check this by FOIL. First gives us x squared, outer minus 5x, inner plus 6x, giving us the plus 1x, the last minus 30. The two numbers, 6 and minus 5, they multiply to the minus 30, so the last will work out. They add to the plus 1. Okay, so the middle term will work out here. We now have this in the form, say, AB equals 0. If AB equals 0, we know either A equals 0 or B equals 0. So that's what we're going to do right now. We're going to set the numbers. Think of these as numbers. X plus 6 is one number, x minus 5 is another number. The product of two numbers equals 0. So either the first number is 0 or the second number is 0 or both. Okay, if x plus 6 equals 0, subtracting 6 from both sides, we get x equals minus 6 as one possible solution. And here, adding 5 to both sides, we get x equals plus 5 as the other solution. And as with all equations, we can check our solutions by going back to the original equation, x squared plus x equals 30. First, we'll substitute in the minus 6. If we've done this correctly, then minus 6 squared plus minus 6 should be equal to 30. Always go back to the original equation that you were given. This is plus 36 minus 6 should be equal to 30, and of course 30 is equal to 30. It checks out. Similarly, let's check out the plus 5. Substituting into the original equation, 5 squared plus 5 should be equal to 30. 25 plus 5 should be equal to 30. And once again, this checks out. So yes, we have found solutions to this quadratic equation. And by the way, a quadratic equation will have at most two real solutions. It doesn't necessarily have two real solutions, okay? But it may have, the most it can have is 2. Okay, just to show you other examples of quadratic equations, something like x squared plus 4 equals 0. This particular quadratic equation has no real solution. Okay, we cannot factor, okay, this. And later on, we will go through other methods, and we'll see that no matter what we would try here, we could not find an x value that we could substitute in and make this a true statement. If you were to say, subtract 4 from both sides, you can see why. If there were an x, okay, that you could plug in and make this into a true statement, then x squared would have to be equal to minus 4. And there's no x that you can think of, be it positive, negative, 0, which when squared is going to come out to be negative. So this has no real solutions. Okay, you could also think of, say, x squared minus 2x plus 1. Here's another example of a quadratic equation. This one does factor. You have everything on one side equal to 0. This factors into x minus 1 times x minus 1, giving you x squared minus 2x plus 1, two numbers which multiply to plus 1 and add to minus 2. And of course, you can see what happens here. You get x minus 1 equals 0, x minus 1 equals 0. We get x equals 1 both times. Okay, so the most you can have is two distinct real solutions to the quadratic equation that we had, like we had over here, minus 6 and plus 5. You might have no real solution, or you might have one solution, one distinct solution here. It's sort of like occurring twice. Okay? But it's basically the only solution is x equals 1. 3x squared equals 2x. Here we have a quadratic equation. Okay, we would start by putting this into standard form. That is, we subtract 2x from both sides of the equation. It's a little bit different from the one that we considered before because we don't have a trinomial here. We're missing the constant term. If you have ax squared plus bx plus c equals 0, the c term is missing. But the factoring on such a problem is very simple because both terms have an x in them. In other words, you can just pull out a common factor. Okay, so it's very simple. They both have x in it. You pull out the x, and you factored it to x times 3x minus 2. Checking, we have 3x squared minus 2x, just distributing the x. So it's factored in the same way. We still have like ab equals 0. Still think of it the same way. ab equals 0, so you set each of the numbers equal to 0. So you get either x equals 0 or 3x minus 2 equals 0. The x equals 0 you don't have to go any further with. The 3x minus 2 equals 0. You get 3x equals 2. Dividing both sides by 3, x equals 2/3. Okay, there are two solutions here, 0 and 2/3, and you can check them going back into the original equation. 3 times 0 squared should be equal to 2 times 0, and of course you get 0 on both sides of the equation. 0 equals 0. And with the 2/3, we would want to show that 3 times 2/3 squared should be equal to 2 times 2/3. On the left here, we have 3 times 4/9, and on the right, we have 2. This is really 2 over 1 times 2 over 3. This is 4/3. And of course, 3 times 4/9, you can divide numerator and denominator here by 3. 3 goes into 9 3 times, leaving you with 4/3 on the left and 4/3 on the right, and it checks out. So we have two solutions, x equals 0 and x equals 2/3. Okay, I want to point out a wrong way of solving this problem, which many people seem to use. Okay, I know this is the correct way. You put it in standard form, you factor, you set each factor equal to 0. Okay, a wrong way of solving this, and maybe if I show it to you, you won't do it. Okay, this is the wrong way. The wrong way is to divide both sides by x, to say 3x equals 2, x equals 2/3. This way you get only one of the solutions, x equals 2/3. You do not get the other solution, the perfectly legitimate solution of x equals 0. The problem here is when you divided both sides by x, you assume that x was not equal to 0. But there's no reason that x couldn't be equal to 0 in this particular problem. And x equals 0 is the other solution, which you've completely bypassed by this method of solution. Okay, so this is the wrong way of doing it. It gives you only one of the two correct solutions here. X minus 8 times x plus 2 equals 24. Some of you looking at this might say, oh, she's getting easier now. She's giving it to us already factored. I'm not giving you anything. I gave it to you factored, but the right-hand side is not equal to 0. It's equal to 24. You can't then say, for example, x minus 8 is 24, x plus 2 is 0, or anything like that, or pick factors of 24. It is not in standard form. So this is a little harder than the ones we've done so far. It's not easier. It looks easier, but it's not. First, you'd have to multiply this out by FOIL. Then you have to transpose or subtract 24 from both sides. Then you'll first have it in standard form, and then you factor and you start the problem. Okay, so don't be deceived into thinking that this is an easier problem and that it's already factored. It's only good for you if it's factored equal to 0 on the right-hand side. Otherwise, you've got to start all over. Okay, so let's multiply it out. First, we get x squared. Outer is plus 2x, and inner is minus 8x. That gives us minus 6x. The last terms gives you minus 16 equals 24. Now, subtracting 24 from both sides of the equation, we get x squared minus 6x minus 40 equals 0. And now you have your quadratic equation in standard form, and now you can start with the factoring. We're looking for two numbers, okay, which multiply to minus 40 and add to minus 6. Okay? Minus 10 and plus 4 will do it for you. They multiply to minus 40, they add to minus 6. Checking by FOIL, we have x squared plus 4x minus 10x, that's the minus 6x, minus 40. Okay, this is now in the form like a, b equals 0, so we set a equal to 0, and we set b equal to 0 to get the possible solutions. X equals 10, and x equals minus 4. Checking, and always back to the original equation, the x minus 8 times the x plus 2 equals 24. We have 10 minus 8 times 10 plus 2 should be equal to 24. And here we have 2 times 12, which of course is equal to 24. On the right, we have, plugging in the minus 4 up here, minus 4 minus 8 times minus 4 plus 2 should be equal to 24. This gives us minus 12 times minus 2, which of course we know is equal to 24. Minus times minus plus 24. So both of these solutions do check out. And once again, I want to point out that just because an equation cannot be solved by factoring does not mean the quadratic equation has no solutions. So in the future tapes, we will be learning other techniques for solving quadratic equations if we can't factor. Okay, let's try another equation. This time, I'm going to give you one with fractions in it. 6 over x squared minus 1 minus 1/2 equals 1 over x plus 1. Okay. Now, with any fractional equation, the first thing you would try to do would be to remove fractions, or it's to multiply both sides of the equation by something so that all fractions would cancel out. Well, we choose to multiply both sides of the equation by the LCD, the least common denominator of all the denominators in the problem. We need to find the LCD, of course, we factor each denominator completely. X squared minus 1. That factors into x plus 1 times x minus 1. 2 and x plus 1, of course. That's as far as you're going to go with them. To get the LCD, we take each factor, the greatest number of times it appears in any one denominator. Okay, x plus 1 appears here once, no times, once, so we need x plus 1. 2 appears no times, one time, no time, so we need it. X minus 1 appears one time, no time, no time, so we need that. Okay, don't make the mistake of thinking you need x plus 1 twice because it appears here and here. We're not counting up the total number of times it appears, but rather the greatest number of times it appears in any one denominator. It only appears once, so we only put it in once. That's the LCD. If we multiply both sides of this equation by this, we will clear all fractions. Of course, as when we studied fractional equations earlier, when you multiply both sides of an equation, okay, by an LCD involving the variable, you always run the risk of bringing in solutions that are not solutions to the original problem. Okay? And we'll see this a little bit later today. But right now, I just wanted to mention that you, of course, although you check all your equations, you must definitely check, especially fractional equations. Okay, the other equations, like the one we had over here, okay, I'm checking basically to make sure I haven't made any arithmetic mistakes or any numerical mistakes here. Okay, I'm checking just the algebra, the arithmetic. Okay, but with fractional equations, it's a whole other thing. Okay, it's possible that you do everything correctly and you still bring in an extra solution to the problem that's not really a solution to the original equation. Okay, so it's very important to check fractional equations. Okay, let's go back up to the top here. We have found the LCD, which is 2 times x plus 1 times x minus 1. And we'll multiply both sides of this equation by this quantity. And if you multiply both sides of the equation by this quantity, that means you multiply each and every term by this quantity. So first, it's 2 times x plus 1 times x minus 1 times 6 over x squared minus 1, which of course is x plus 1 times x minus 1. Then take away. You'll multiply now the LCD, 2 times x plus 1 times x minus 1 times 1/2 equals the LCD, 2 times x plus 1 times x minus 1 times the right-hand side, which is 1 over x plus 1. Okay. In the brackets here, I have the original equation, 6 over x squared minus 1 minus 1/2 equals 1 over x plus 1. I've multiplied each term by the LCD. Okay, in the first term over here, of course, the x plus 1, the x minus 1 cancel, and I am left with just 6 times 2, or 12. Take away. Here, the 2's cancel, and I am left with, take away x plus 1 times x minus 1. And finally, on the right-hand side, the x plus 1's cancel, and I'm left with just 2 times x minus 1. This is 12 minus, you first do the multiplication, of course, it's just x squared minus 1, equals 2 times x minus 1. We're now going to distribute this minus sign, which is really like a minus 1, through the parentheses here, and distribute the 2 through the parentheses there, giving us 12 minus x squared plus 1. It's minus x squared minus a minus 1, or plus 1, equals 2x minus 2. All right. We have here 13 minus x squared, combining the 1 and the 12, equals 2x minus 2. 13 minus x squared equals 2x minus 2. To put it into standard form, everything, say, on the left side equal to 0. I will now subtract 2x from both sides, and I will get 13 minus x squared minus 2x is minus 2. And finally, I will add 2 to both sides. 15 minus x squared minus 2x equals 0. Okay, it's in standard form. I would prefer to write it, though, say, as ax squared plus bx plus c equals 0. So let me just rewrite this as minus x squared minus 2x plus 15 equals 0. Okay, I just rearranged the terms. That's all I've done. Put the plus 15 at the end. Okay, now before I start factoring this, I find it much easier to factor if the lead coefficient is plus 1. So let's multiply both sides of the equation by minus 1. Okay, this will change all the signs on the left, give you minus a minus, so plus x squared plus 2x minus 15. Of course, the right-hand side will still be 0. 0 times minus 1 is 0. We are now ready to factor. We are looking for two numbers which multiply to minus 15 and add to plus 2. And of course, the answers are plus 5 and minus 3. Let's check. We have x squared minus 3x plus 5x. That's plus 2x minus 15. Okay, we set each of the factors equal to 0. It's like AB equals 0, so we said x plus 5 equal to 0 and x minus 3 equal to 0. To get two possible solutions, x equals minus 5 and x equals plus 3. With fractional equations, the best I can say at this point is that they're possible solutions. I won't know for sure if they're solutions. Even if my arithmetic was, say, correct, I won't know for sure if they're solutions until I've checked. So let us go back to the original equation for our check. The original equation was 6 over x squared minus 1 minus 1/2 is 1 over x plus 1. Before we've done anything to it, including multiplying by the LCD, you go back to the equation in the original form here. Now we want to check. Let's check the x equals minus 5 first. We substitute in, we have 6 over minus 5 squared minus 1 minus 1/2 should be equal to 1 over minus 5 plus 1. Now, 6 over minus 5 squared, that's 25, minus 1 is 24. Minus 1/2 should be equal to 1 over minus 5 plus 1, that's minus 4. Minus 4. Now, 6 over 24, of course, reduces to 1/4. Minus 1/2 should be equal to minus 1/4. Instead of 1 over minus 4, you can just think of that as minus 1/4. But since 1/2 is 2/4, what we have here is 1/4 minus 2/4, which of course does come out equal to minus 1/4. 1/4 minus 2/4 minus 1/4 equals minus 1/4. It checks out. Now let's check out the other solution, x equals 3. Back in the original equation, 6 over x squared minus 1 minus 1/2 equals 1 over x plus 1. So substituting in the x equals 3, we get 6 over 3 squared minus 1 minus 1/2 should be equal to 1 over 3 plus 1. 6 over 9 minus 1, that's 6 over 8, minus 1/2 should be equal to 1/4. 6/8, of course, that's 3/4, minus 1/2, which is 2/4, is equal to the 1/4. Here I have the extra space, so right to the end. The left side is 1/4, the right side is 1/4. 3/4 minus 2/4 equals 1/4. So both solutions do check out. Okay, therefore, minus 5 and plus 3, both of them are solutions. These are both solutions. Okay, but we will not know for sure until we've done the check. I want to solve this equation for x. X plus 6 over x minus 2 is equal to 3x over x minus 2. Once again, we have a fractional equation. If you would like to try this problem on your own, you can shut off the videotape machine, work it out, and turn it back on when you feel you've completed the problem. Okay. Here, it's very easy to find the LCD. The denominators are 1, x minus 2, and x minus 2, so the LCD is simply x minus 2. To clear fractions, we just multiply all parts of this equation by x minus 2, each and every term. So we have x minus 2 times the x plus x minus 2 times the 6 over x minus 2 equals x minus 2 times the 3x over x minus 2. I've multiplied each term by x minus 2. Well, in the first term, x minus 2 times the x, distributing the x, I get x squared minus 2x. Okay, in the second term, the x minus 2's here cancel, and I just have plus 6 equals, over on the right-hand side, the x minus 2's once again cancel, and I just get 3x. Subtracting 3x from both sides of the equation, I get x squared minus 5x plus 6 equals 0. We are now in a position to factor, looking for two numbers which multiply to plus 6 and add to minus 5. And the answers are minus 2 and minus 3. Checking, you get x squared minus 3x minus 2x for the minus 5x plus 6 equals 0. We now have a, b equals 0, so we set each of the factors equal to 0, getting two possible solutions, x equals 2 and x equals 3. But until we check, in a fractional equation, until we check, that's what they are, possible solutions, until we've actually checked to see if they work out. And remember, you don't check in the x squared minus 5x plus 6 equals 0. You go back to the top, to the original equation. Let's do the check. The original equation was x plus 6 over x minus 2 equals 3x over x minus 2. And we're trying to check our two answers. The first answer we got was 2. The second answer was 3. Checking x equals 2, we get 2 plus 6 over 2 minus 2 should be equal to 3 times 2 over 2 minus 2. And of course, we see that we have trouble because we have 2 plus 6 over 0. Okay, oops. We're not allowed to have division by 0. Obviously, something is wrong here. This is not checking out. It does, by the way, check out if you were to use the x squared minus 5x plus 6. Okay, if you were to try to substitute into x squared minus 5x plus 6 equals 0, it would check out. You would get 10 minus 10 equals 0. The thing is, you haven't made a mistake here. What you've done is multiplied both sides of the equation. Now, to get an equivalent equation, you can only multiply both sides of an equation by a non-zero quantity. When you were multiplying both sides by x minus 2, you weren't sure at that moment whether x minus 2 was 0 or not. Okay, so it is possible. Of course, what happened was that when x equals 2, x minus 2 is 0, you were multiplying really by 0. And that can result in an equation which is not equivalent to the original one. Okay, so it is very important to check. We haven't done anything wrong, except we did get a solution which is not, we got an answer which is not a solution to this problem. So x equals 2 is not a solution. Let's try x equals 3. Going to the original equation, you get 3 plus 6 over 3 minus 2 should be equal to 3 times 3 over 3 minus 2. We have here 3 plus 6 over 1, which is just 6, should be equal to 9 over 1. 9 over 1 is 9, and of course 3 plus 6 is equal to 9. So x equals 3 is a solution. It's the only solution. X equals 2 is rejected. Okay? This particular equation has only one real solution, x equals 3. Okay, this is not a solution to the problem. And that brings us to the end of this tape.